everybody. Thank you for coming to our talk about inclusive architecture, or more importantly, us introducing the PAMSTACK, which is our new framework for creating sustainable development teams.
So you might wonder, what is the PAMSTACK? And the PAMSTACK is actually, there's three pillars to the PAMSTACK. So there's process, abstractions, and mentorship. These are the three pillars. We're going to talk a lot about how inclusive architecture basically enables your developers today. And what it should enable are a few different things. Number one, there should be less maintenance for everybody. So creating a code base that actually allows people to contribute easily and is not just reliant on a handful of senior developers. Also less stress on your team, which hopefully creates more retention because people don't get burnt out as much, and hopefully that saves your team money. It should also enable easy conflict resolution, so more team buy-in and cooperation internally. Also, lower the cost over time of developers and churn, and also lower the cost of the project. So we'll be recommending a lot of different tools that will take some strain off of all your developers instead of having to, hand roll all the things. Also more inclusion, so with a more inclusive architecture and a more inclusive code base, etc., this will give you the ability to hire more juniors, which is going to allow for a more diverse set of candidates on your team.
All right, but first we'll introduce ourselves. So my name is Rob Ocel. I'm a senior developer at This.Labs. I'm also a host of a couple of our podcasts, like the Modern Web Podcast and the This.Labs podcast.
And my name is Tracy. You can follow me on Twitter at LadyLeet. And like Rob said, we are part of This.Labs, and we do a lot of JavaScript consulting. So everywhere from Angular, React, Vue, Node, Polymer, web components, et cetera, et cetera. I'm also a GDE for Angular, an MVP for Microsoft, and I'm on the RxJS core team. So part of an inclusive architecture is including everyone, right? So then why do a lot of teams feel like they can't include juniors? I went to Twitter to ask this question, and John Cooperman, one of my friends, replied and said that a lot of companies can't begin to imagine taking on juniors because they take up too much time. They always say there's no bandwidth to mentor, or the team's already too junior, or maybe it's not worth training somebody because they're going to leave anyways. But the thing a lot of us don't realize, or a lot of these teams don't realize when they say that, is that it's not always the fault of the juniors and their lack of knowledge. It's actually typically a fault of their own or of those teams. So it's really coming to that understanding, and coming to the understanding that if you're not making inclusive decisions within your code base, then these are going to actually affect everybody, not just juniors.
So let's look at some of the examples of ways or reasons that things that teams do that actually harm juniors. So for example, they might have really poor onboarding documentation. This means that all your juniors have to constantly feel like they have to ask everybody how to do everything, whether that's how to help with the code or how to follow a process, or even who to ask the right questions to. The teams might rely on individual excellence, and this means then that the seniors have to micromanage the juniors intensely because the team generally expects everyone to to be responsible for not putting any errors into the code or not making any mistakes in the process. And if they don't get babysat, then those mistakes end up falling directly on the laps of their users, which causes those junior developers to feel guilty or feel like they're doing something wrong or that they don't belong. Teams might have superiority complexes, might be made up of seniors that feel like they've already put in their time, they don't have to deal with juniors, they should only have to deal with other seniors like themselves, it's beneath them to answer some of the questions or to babysit those juniors, and then people don't collaborate. This kind of creates that rise of sort of the rock star asshole developer that some of us might be familiar with. And lastly, there's no review or mentorship. So in those kind of situations, the juniors just stay perpetually junior. Because without input, without help, without mentorship, without being told kind of, where to correct themselves or what to do, then there's no room for growth. Now, one thing that we'll see is that this doesn't just hurt the juniors. There we go. This also hurts your mids and your seniors and your architects as well. These same things that are not working for juniors are not working for the rest of your teams. So for example, with poor onboarding documentation, this just means it's really difficult to hire people and onboard them. The same questions that the juniors would have to ask, those mids and those seniors that you just onboarded have to spend asking, and all of your team just is constantly feeling like they have to babysit new people. When you rely on individual excellence, then suddenly your team starts having those hit by a bus fears. You have those people on your team that you're like, we can't possibly lose that person, it would take way too long. Nobody knows the system like that person knows the system. When you have a superiority complex on your team, that means that you're going to have a lack of inclusion, right? You have these people who are siloing based on what they know, based on who they think is worth it, based on who they think is worthy or contributing on the team on the same level that they are. And therefore, people just aren't going to be forming cohesive groups or feeling like they're part of a common team. And of course, review and mentorship hurts everybody. It's not just juniors that need that mentorship, right? Everybody needs to know where the next rung is. They need to be mentored into that next role, right? If they're mids, they want to be seniors. If they're seniors, they want to be architects, and wherever else they want to go in their career after that. So if there is no advancement or if there's no mentorship, then nobody's moving and everybody just feels like their careers are stuck in neutral.
So then the question is, what could a project look like with an inclusive vision? And if you're adopting this inclusive vision, that means that all of a sudden success on your team is not person dependent, right? It also all of a sudden becomes team dependent. And that's because there's more process around things. There's more mentorship. You should have and be able to have a constant stream of developers across a spectrum of experiences contributing to the team. This allows for more specialization and more experience. Also, people aren't going to be locked into their positions, which is very helpful as well. Also, you have less burnout and less panic hiring, meaning you're not just going to have to say, oh, okay, I'm going to wait until somebody quits to hire somebody else. And that way you're able to hire people more seasonally, which allows you to be more, have a more concerted thought around hiring the right person, right? Instead of like, oh my God, you're okay, like let's just hire you right now. Also more innovation, more excitement, and more learning. So as much as, you know, mentorship and things like that is good for junior developers, it's actually really great for senior developers as well, because they feel validated, they feel important, they feel like they have people looking up to them, and they also feel challenged because, you know, teaching somebody is actually harder than just coding. Oh, so the PAMSTACK, again, it consists of 3 different tiers, right? Process, abstractions, and mentorship. And we're going to go into the first one first, which is process.
Yeah, so as Tracy said, we're going to start with process. And I know a lot of you, your eyes already glazed over, right? You hear process and you immediately zone out. Just ask that you give us a couple minutes here, and maybe we'll win over most of you. So process is an interesting thing. And I think what's interesting about it is that some people don't really appreciate its effects on their teams. So what I have here is a description of a team that is operating without process. And this is what their life is like. And as I'm reading this, I want you to think about whether this accurately describes any teams that you've maybe worked on in the past or maybe that you're working on right now. So this description reads that processes on these teams are usually ad hoc and chaotic. The organization usually does not provide a stable environment to support processes. So success in these organizations depends on the competence and the heroics of the people in the organization, and not on the use of proven processes. In spite of this chaos, these organizations often produce products and services that work, but they frequently exceed the budget and schedule documented in their plans. These organizations are characterized by a tendency to overcommit, abandon their processes in a time of crisis, and be unable to repeat their successes. So if you're like me, at least on some of your teams, you feel a little bit attacked right now after hearing this. And you just sort of understand that the takeaways about this are that a lack of process on teams means that you have this dependence on rockstar developers. You have a constant overcommitment and a feeling of just being rushed all the time and not really being sure why. Whether projects succeed or fail, nobody can seem to understand it. It just feels completely arbitrary. Projects will always go over schedule and blow through their budget, and there's confusion over what the roles are, who's responsible for what on the team. So we can solve this with process, but process doesn't have to be endless meetings or fancy buzzwords or mounds of paperwork. There is a better way. And so I thought I would tell you a story about a team that I was on once. We hated our corporate process for all the cliche reasons, right? We thought it was busy work. We're like, we're developers. This isn't something we have to do. You just want us to write this down so you can sign off on your compliance paperwork. You know, we're too busy, these types of things. And our boss actually covered for us. And he gave us a lot of cover so that we didn't have to do this stuff and made excuses to his bosses. But one day that boss came to us looking a little shaken. And it turns out that he was actually dragged out on a call in front of all the senior leaders and chewed out for not implementing the process. And the ultimatum was clear, right? He said, we need to implement this process or we're all going to be fired. So begrudgingly we complied, But we had one stipulation. We said, if we're going to do this, we don't just want somebody to force it on us. We want to do it ourselves. So we're going to split up this process across the team. We're going to do it in a way that makes sense to us. We'll meet your objectives, but we want to do it ourselves. So you fast forward a couple years, and this actually started to work. We actually saw real results, and we ended up becoming the process paragons in the company. We were training other teams, and the teams were asking us why this was working so well for us. And it turns out that the reason that we liked doing it is because the more that we did, the more relaxed we were. Right? We realized that some of the hype around process actually ended up being true. Instead of making us more busy or more bogged down with busy work, it actually made us more relaxed and more able to focus on our important work. The process had set us free.
So again, if you kind of look at that and you look at if you're doing process consciously and deliberately, that means that all of a sudden your team has clearer expectations, which makes you happier. There's expanded team engagement and cooperation. There's also less single points of failure, which is really helpful. Also less stress during those crazy times, right? And hopefully also reduces conflicts and power struggles.
Okay, so there are many different process methodologies. So no single one is best. I will say that the description I read earlier is from the CMMI process. If anybody's familiar or has done that, it was really big in government contracting. But all the different methodologies kind of have the same general format. And it goes a bit like this. So first, we define our expectations. So when times are calm and everybody has level heads and we have the ability to think, we write down what we expect people to do in various situations. And this means writing actual plans, and we'll show an example soon. Next, we describe how to meet those expectations. So we want to help people actually meet those plans, and that means creating checklists, step-by-step instructions, doing trainings, things like that. As we're executing against those plans, we want to verify that our expectations are actually being met. And this means that we're going to review all the things. So not just code, as everybody's familiar with doing, but we'll review designs and plans and meeting minutes and things like that to make sure that we're actually following those plans that we said before. We want to put people in charge of that process and then make them ensure that people are in compliance with it. As we're doing that, we want to record results. We want to find meaningful metrics that are useful to us and give us information about how we're doing, and then we're going to track those. And finally, after a little while, we want to take a break and then review all the things that we've done. We want to say, hey, were our plans accurate? Were they good? Did they give us all the information that we needed? Did we execute well against those plans? And how about those metrics? Did they give us information that was useful as we're reviewing? Should we take different metrics? Should we abandon the ones that we have? Or so on. So we're going to talk about the first part first. Makes sense. Which is planning. And when we're creating plans, we want to ask ourselves a couple questions. Some of this might be obvious, but it's actually really important. So for example, we want to ask what needs to be done. Obviously, that should be really important with our plans. Who's going to do those things? How should it be done, and when should it be done? Also very important to know when to actually implement some of these processes. Now we're going to actually write these things down, and then we're going to follow them. So here's an example or some excerpts of a plan that was from a team that I was on before. This is our verification plan, and it's a subset around code peer reviews or code reviews. So every process should start out at least with a purpose, right? So here we're going to say what this process is, why we think it's important, why we follow it, and roughly what it means. And this is not only useful for the team to understand and get buy-in that this is actually something they want to commit to, but it's useful for new people to the team or juniors on your team to understand why it is that what they're reading is important. Then, of course, you want to go through some roles and responsibilities. Clearly lay out what are the different people that are participating in this process and what's expected of them. It's okay if people that are participating in this process might occupy more than one role at a time or more than one role in between different processes. In this case, it might be obvious that somebody could be the author of a code review one time and a reviewer in another one. Then, of course, you're going to lay out all the steps in that process. Now, I haven't laid out all the steps, but I did call out one that I think is really important. And this is a really great thing that plans can give you in a process, which is that it can help deal with all the exceptional circumstances. So for example, it's probably happened to many of you in a code review that the author and the reviewer disagree about a particular change in the code review, right? And the question is, how do you resolve those conflicts? You could have the author always be right. In other words, they decide what goes into the code and they can ignore the reviewer. Or you can say the reviewer is always right, so anything the reviewer says, the author has to change. Or worse still, you could leave it down to whoever has the most power in the relationship or whoever yells the loudest. Instead here, what we've called out is that we want people to actually try to mediate the conflict themselves. But if they just simply can't see eye to eye, then the tech lead gets to make the call. This depersonalizes the conflict and makes it very obvious about what's expected. People don't feel like they have to worry about the arbitrariness of this decision. They'll know that maybe they're wrong this time, but they'll win the next time. We've also called out another exceptional circumstance here, which came out in one of our review sessions, which is that what happens in a code review if you find something that you want to change, but there isn't time to change it in the code review? Well, we've called out the ability for people here to say, okay, that's fine, take that defect, put it in the bug tracking system, and then pass the code review. Now, again, that might be something that the different parties would come to an agreement on in the moment, but in this case, they don't have to think about it anymore. The process has already told them what they need to do, they just have to follow it.
So the second thing is training, right? So anything that doesn't fit into the general process or needs to be a little bit more detail oriented, you can add into checklists. I really love checklists. So, my last company, we had to onboard 20 people a week and teach them exactly the same thing every single week. It was a little bit crazy. Can you imagine onboarding 20 people? But what I ended up doing instead of having like 20 meetings was I just recorded every single thing I did and put it into the process, right? Checklists as well. So, it helps. If you're error prone, who can remember the 10 million things you have to do? So you have a checklist, you always have guidelines to go back to. In addition to that, this also really helps with juniors, right? If you're too busy or senior developers are too busy and you need to onboard them or teach them something, you can just give them a checklist. And then also we all get busy and stressed out, if there's deadlines or if it's Friday, and we'll forget and make mistakes, right? But this decreases the amount of pressure that you have to do to memorize everything. And again, you can just fall back to that checklist. Here's an example of a code review checklist, and you'll see here that all of these are basically for the author. So these are the things that the author should do before submitting a code review. There's certain things that might be specific to this specific code review checklist that was created, but you can create your own internally. And if we go further down into the checklist, you'll see that this is for the people who are reviewing, right? So again, some of these things are universal, for example, like, code validates input parameters or, something like that. But what this ended up doing was reducing a lot of the issues that were seen in the different code. It just really helps overall to have things like this.
Okay. So while people are doing these things then, and they're actually implementing the processes and they're following the checklist, we want to make sure that everything's going well. Because a big part, if you haven't gathered it, of this process and this whole approach is review is really, really important and really useful because we want to have each other's back. So some of the positive effects of reviews, the most obvious one is improved quality. We want to catch issues before they make it to later parts of the development lifecycle, and whatever that means, right? It's always more expensive to fix something the longer you wait. So the more places where you have review and you have people checking on what's being done, the less expensive and the better off you are as far as quality. You also get the cross-pollination of ideas, right? So not only, for example, in a code review, does the author learn from the reviewers reviewing their code, but many times the reviewer also learns from the author because they get to see the novel approaches that that author took to solving a problem. Been in many cases where people have had conversations like, I had no idea that that library method even existed. You also get redundant learning. So when you're forced to review code that you're not familiar with, suddenly now there's a second person on the team that has at least some knowledge about that area of the code or that part of the process, and that they can stand in if necessary. And then you have reduced stress and you eliminate the fear of making mistakes, right? So whenever you know that somebody has your back, that somebody's going to review a document that you're going to send to the client or review a piece of code that you're going to check in, you don't get so anxious that you're going to miss something and make a mistake. And it seems paradoxical that you can relax a little bit and still improve quality, but it's true because that anxiety isn't actually helping you. It's actually clouding some of your, clouding your thinking. And so taking that away actually makes you more comfortable and more able to make positive outcomes for your clients. Now, one mistake that a lot of teams make is that they only review code, but you can review everything. And I've actually reviewed all of these things on one or more teams in the past. So you can review things like meeting notes to make sure that you all heard the same things, that you all agree on what you promised to the client or what the client asked you to do. You can review designs and requirements in much the same way that you can review code, and therefore catch issues much earlier in the development process. You can review tests to make sure that they'll actually catch things, or that they're not missing tests. That would be very important to make sure that you don't get defects through to production. Obviously reviewing code, and you can review the plans to make sure that everybody agrees what they're about to have to do and be enforced that they do. And you can even review communication to the clients. This might seem overkill, but it can be really good for a team that to enforce a constant tone, a consistent tone, and that you're not over-promising to the client. That somebody's offhanded comment in an email doesn't suddenly become everybody's nights and weekends for the next couple weeks.
So the next thing you want to do is, of course, measure what you're doing and make sure you're actually recording your results, right? Try to capture as much data as possible. So you could capture things like churn. So, figuring out what stressed you out, what was working, what didn't work in a project, and what to improve later. Time estimates are really important to review as well. So is what you're giving to a client or to a product owner maybe what you wanted to actually give them, or are you spending way more time doing something else, right? Like I think with apprentices, one thing that we've realized over much time is that apprentices take so much longer and need so much more time with mentors, right? So as we review that, we make sure to change that for our ongoing process. Also making sure that you're just consistent with collecting metrics so you actually have good data to look back on. And also don't worry about finding the perfect metric. I think a lot of people, if you're looking to implement any metrics, you're like, oh, well, what should we measure? What should we do? How should we do it? And you spend too much time thinking about that instead of just saying, hey, I think that this might be an interesting metric to review. Let's go ahead and do it for a while. And then afterwards evaluate it and say, did it work? Did it not? And if it doesn't work or if it's not useful, then stop collecting it. I personally hate it when some of our marketing clients are like, let's review all the metrics, let's collect all the things, and then they never look at it. Kills me. But it makes me want to stop doing it. So anyways, and this is why it's actually very important if you're going to be making your team get metrics to actually review them, right? You need to stop, pause, be introspective about it, and allow the person who's actually in charge of collecting the metrics to actually implement some new ideas of, oh, hey, this worked, this didn't, etc. When you're reviewing, you should be asking, how did we do? How can we improve? What do we need to change? And was anything that we actually did useful?
Right, so as an example, on one team that I was on, at one of our review sessions, one of our team members came up and said, I've been looking at the software estimates that we had, and I realized, I did a little bit of math on it, that we spend about 25 to 33% of the time consistently of the time it took to implement code in the code review. And we said, wow, that's really cool. That's held over so many reviews, right? And he said, yeah, it actually does. So what did that do for us? Well, it did a couple things. First of all, it meant that when we were reviewing future estimates, we had valuable information because we could look at how much time they said in the estimate it was going to take for code review, and then we could say, I don't know, only 10%? That doesn't sound right, based on some of the metrics we have. Are you sure that's the right number? And then for people that were doing the estimates, suddenly they had a much easier way because they could add up how long they thought it would take to implement something and then put an easy number down for the amount of review hours because they didn't have to think uniquely every single time, well, how many hours will this take to review and how many hours will this take to review? So not only did the process make us smarter, it also made us faster because we had gleaned those insights into our own processes. This is also a great process to do, to just bring everybody together and make them feel like they're part of the team. When everybody controls part of the process and they all get a chance to say how they want to improve the team, they really feel bought in. They feel like they have control, that they have some ownership over some part of the team, no matter how long they've been with the team, whether it's been a week or a year or longer.
So going back to our PAMSTACK, the next one is actually going to be abstractions, and I really like this. I really like this topic, this pillar. So the first thing we kind of need to acknowledge in the development world is that web development is hard, right? If you think about performance, security, accessibility, responsive design, progressive enhancements, browser compatibilities, like each one of these is a conference talk in its own. Each one of these, there is an expert in that. But as web developers, we are supposed to be experts in all the things. So That being said, this basically leads to a lot of JavaScript fatigue, right? Even amongst the mid and senior developers, we're all feeling stressed out of, oh my gosh, the web is constantly evolving. There's constantly new requirements. And even worse, complexity is starting to become a barrier to entry in our industry. Every time we advance our understanding of what something means, accessibility, for example, all of a sudden there's like 10 new things that are actually become the standard, right? So keeping up is really difficult. And you can see this if you just do a simple Google search, for example, of juniors. So juniors are constantly overwhelmed. They, don't know what they're doing, et cetera, and they're searching the internet all the time. So the great thing about our industry, though, is that there are a lot of things that can actually solve this and help this. Frameworks are a great example. So it might be easier as a senior developer to just be like, hey, I could just handwrite this myself, vanilla.js, etc. But, I'll give you a great example. When I was first learning JavaScript, for the first 2 weeks, I was like, oh, this is so cool. I can do this, I can do this, I can do this. And really, I just wanted to make a bunch of images like move on a screen, and I got really excited. But then my teacher at the time just kept saying, okay, keep going, keep going. And then one day he finally was like, okay, here's Ember. I'm going to show you Ember. I didn't want to, but I'm going to show it to you. And, Ember is so opinionated. It spun up a dev environment for me, and I spent the entire weekend building websites and launching them. And they were so beautiful. They're still pretty right now, right?
And so for me, I was a desktop developer for about 8 years before I came back to web development. I'd done some web development when I was a teenager, but it had been a long time. So even having all that experience in development, when I came back to the web, there was just a lot of things about the mental models that didn't make sense to me. Some of it was just really magic how data went through the tubes. So cookies and AJAX and headers and Google OAuth and all this stuff was just, it was pure magic to me. But the ability to use AngularJS on the team that I was on at the time helped me use the development skills that I actually knew in order to actually contribute to the teams that I was on and deliver products to my customers. So one example of a framework that makes it easy to do the right thing by default is actually Google's AMP. If anybody was here for the AMP Roadshow a couple days ago, some of this you've probably already heard. But for those of you that didn't, AMP is a library, a set of best practices, and accompanying tooling that aims to help developers of all experience levels make better, faster, and more accessible experiences. Now, I bring them up to say that this is a great example of how frameworks can really hide a lot of complexity from your team, your junior developers and your new developers, and really empower them to make really cool things for users without a lot of overhead on their own knowledge. So for example, AMP has a component called AMP image. It's just a wrapper around the HTML image tag. But this is a list of all the things, or at least some of the things, that they do for you automatically under the hood without you even having to realize it. So they might resize your images based on the size of the user's viewport. They can efficiently load or preload those images, but depending on how far down the user has scrolled on the screen and how far down the image is, how many viewports down the image is on the page. It can automatically calculate reasonable values for the sizes attribute. And it can display image as a placeholder while the image loads, or show a fallback image if something were to fail. You can also, if your AMP page is in the AMP cache, those images might actually be automatically converted to more efficient formats like WebP, even if you didn't know that that format existed. And images in the cache could be automatically resized and then added into a source set into your document, so you're doing the most performant thing possible with images without even knowing necessarily that those technologies exist. In the meantime, when you're ready, you can learn how those technologies work and over time replace that with your own knowledge and maybe not have to rely on the framework quite as much.
So I don't know about you, but I'd really rather just use AMP image and be like, look, it's performant. I don't have to deal with all that. So this is why I want to bring up the second thing, which is CLI. So thankfully these days, most of the frameworks come with CLIs, and most of the really cool developer tools that we have these days come with CLIs as well. So again, you can just, you have the framework, but with CLIs, I mean, I would be lost. CLIs do so much for you. So I love the fact that they just spin up a new environment for you. They scaffold up new projects. You get out-of-the-box performance. I mean, you don't need to know what automatic differential serving is, lazy loading, tree shaking, ahead-of-time compilation, right? It just does all of that for you. These Tools are also regularly kept up to date, so you never have to worry about keep staying out of date, looking for the newest releases, et cetera, et cetera. They also help you migrate between major versions of different libraries. Like Vue, for example, you can go from 2 to 3 really easily. And there's tons of documentation around CLIs. So as you're looking to build with CLIs, a lot of times it's not, how do I do X with Vue, but it's how do I do X with Vue CLI. Also, if you're afraid that like, hey, maybe the CLI isn't going to work for my use case, you can always eject afterwards. Also, I really love where frameworks are going these days. So if anybody has used the Vue GUI before or Angular console, it's starting to make web development much more accessible, right? Like you don't need to use the terminal, for example, to be successful. You can just use one of these GUIs and it'll do everything for you.
So as I've already said, modern web applications seem to be getting more and more complex. So these sites can start to have real-time requirements, or use optimistic state updates, or have offline capabilities, or they might use many different APIs to aggregate data together. The use cases could be extremely intricate with lots of edge cases, and the system might be mission critical and require incredible precision in executing its business logic. So how can we actually take these kind of applications and then bring people that are new to our team or juniors into the fold? One of the big things that we can do is by separating the application into potentially different layers, which isolates the most complicated parts of the architecture from the parts that are more accessible to other members of your team, actually building some of those interfaces and those components that your users will use every day. So one example of how you could do this is to break up the application, for example, in the presentation layer, so all the components that your users will actually see. The data management layer, sort of how you move data back and forth between the backend and control that. You could have the services layer, which is where you integrate with all the different APIs or maybe even the different devices that your application uses. And then you can rely on your seniors to set up what Minko Getchev called like a facade layer. And we'll talk about some of the ways that you can do this, but essentially it gives the people that are implementing the interface the ability to have these sort of like hooks or handholds to grab onto that actually drive the backend in complicated ways, but through a rather simplistic or straightforward interface. And one of the ways that people can do that is with state management and approaches like using NGRX or Redux or Flux or MobX or any of those types of libraries. This diagram up on the screen is actually the architectural diagram for Flux itself. So what this allows us to do is to split up our application into state, or information about our application that is important to our users or to our interface developers, or actions, which is kind of like our intent to do something interesting, like save a to-do or save a blog post or open a particular page or a slide. From the effects and the reducers, which is basically like how do you make the backend and all those complicated features that I talk about actually happen and happen correctly in response to actions that people take. Now, these Redux actions are a bit like Amazon buttons, and that's kind of the best way to visualize it, right? So you have these buttons, and all you know is that if you want paper towels, you press the bounty button, and if you want some detergent, you press the finish button. You don't have to know what happens, how it deducts money from your account, how it does the shipping, how it decides what to give you and when to send it. All you know is you press that button, and it does what you expect. And that's what we're trying to do with some of these approaches like the state management libraries. Now, another really powerful tool are state machines, and these are becoming a bit more popular now. So state machines, like this state machine of a traffic light, sort of splits up what are the possible states of a thing and all the transitions that exist between them. And you can actually do this for software. Now, I recognize that even the people in the front row can't read this. That's okay. All you need to see here is that it's complicated, all right? And this is actually a picture of a state machine using the XState library, which is David Piana's library. This was posted on Twitter by Ryan Florence. And this is the state machine that drives his checkout flow for his website. And so it's complicated because it has a lot of edge cases. People might have coupon codes, or courses might be sold out, or people need to register with the website, or their payment processor might reject their payment. There's a lot of things that could go wrong, and what this does is it accounts for all of that complexity completely independent of the technology that he implements it in, so that he knows that if he verifies that this is how he wants people to move through the flow of his website, then that data over on the right will show what the library allows for his interface to bind to. So then he just has to bind this state machine to his interface, and then he has a reasonable assurance that the interface itself is working. This is just another really cool feature of XState, that it actually lets you walk through these state machines in an animated way, which is great for, again, for people that you're onboarding or juniors in your team, that they can play with all the states of the application, see all the edge cases and how you transition between them without having to know how to execute the code, read the code, or even execute the application. Now, another common mistake that we see with a lot of teams is not being more deliberate with their visual design. So for example, a lot of teams will just, the first month of the project, they just are like, yes, let's make another date picker. Or, autocomplete. Autocomplete's really fun to do. Or modals, let's redesign a modal for the 10th time. And how well these are implemented, how accessible they are, how performant they are usually up to the whims of that developer who is re-implementing it. Now there's another effect that I like to call the Bob Ross effect. So if you guys have ever seen this, which is where designers will give developers a spec. But instead of going back to find reusable blocks of CSS that they could use to build that page, instead they just repaint every page like it was a fresh canvas. And you just get these large, unmaintainable blobs of CSS. Then pretty soon, everybody's just using important on all their properties, and then you've lost, right? It's over after that. So we can get around this with using things like design systems, right? So design systems are just shared visual language for your team. Now, these can focus and constrain your options when building interfaces, but they're not actually restrictive. It's another one of these things where you accept the restriction in order to be more powerful. So instead of having these infinite options to define pages in CSS, you have very well-defined ways to lay out your pages. So some of the popular ones, obviously material design, maybe a lot of people have heard about. Shopify's Polaris is also another really popular design system that you can pick up. And they contain a lot of interesting technology for you, for your designers, for your coders, for your copywriters, for everybody in order to implement websites more effectively. And of course, we also love component libraries. So component libraries are just basic sets of reusable components, and they oftentimes implement the requirements of a design system already. So for example, the Material UI library implements the material design spec, or design system. They can also help tackle accessibility, responsiveness, performance, or any of these other complicated things for you. So the Reach UI component library, which is still being built out but is really promising, does a lot of accessibility for you with these very basic components that you can build on and style, but it does the accessibility for you and does it in the correct ways so that you don't have to worry about it and that your users aren't being left behind.
So we've talked about two pillars so far, which is process and abstractions, but now let's go ahead and talk about mentorship. This might be the last one we talk about, but it's definitely not the least important. If you look at why mentorship is so important for teams, you look at Spherion, they just did an emerging workforce study, and it says that if developers aren't growing, they're more likely to look for a new job. In fact, 35% of employees who are not regularly mentored look for a new job within 12 months. So you're losing a third of your workforce if you're not doing mentorship. Also, hiring is difficult and expensive. I can't tell you how many times I'm like, oh God, we have to hire again. Please, no, make it stop. But I love it. I love that we're growing, but it's a lot of work, right? Some studies show that it could cost up to double a developer's salary to recruit a new developer. In addition to that, you have to pay recruiter fees potentially. You have to train them up. It takes time away from your teams, et cetera, et cetera. It's just a lot. I think one note that we want to do is, where is it? Where is that metric? Oh, I can't see it. Oh, I don't see it. But anyways, it's cheaper to keep your people. That is the point, okay?
You don't have to take our word for it. So when we're thinking about creating a culture of mentorship and what that might look like, we like to visualize it in terms of this requirement. So imagine that at your company, on your team, you had this requirement, that no employee could be promoted unless they could nominate someone else to take their current role. What might that mean? How might that change the way that people think about their jobs and getting promotions? Suddenly, it's not beneficial to just selfishly pursue one's own promotions and ambitions. Everybody has to be invested in finding and recruiting and training and retaining top talent because otherwise they don't have anybody to take their place when they want to move up. People also have to be attentive to the contributions of all their other team members, right? If only to look for the people that are excelling and could get their promotion. So we're going to see that rockstar developers start to fade at that point, and rockstar mentors will start to be the people that are actually moving up in your organizations. Now, note, we're not saying that we're not advocating that this will be in all companies, but it is useful to just bring this up in a conversation, with your team and just say, how might things be different if that was actually true? Now, in the interest of time, because we were fixing some stuff, I'll just flash a lot of numbers on the screen here. But what this is meant to show is that even if your rockstar mentors aren't contributing any code, they actually can help you scale your team much faster than teams that rely on individual excellence. So when you hear people talk about the 10x developer, we like to introduce the concept of sort of the 10x mentor, which is this person that helps their teams deliver 10 times the value of a team without them, rather than worrying about individual people delivering 10 times the value that they were before.
It's this idea where you're making don't be a 10x developer, make 10 people on your team 2 times better.
Yeah, right. That's the way it's most easily formulated.
So obviously we know why mentorship is awesome for mentees, but I just wanted to go ahead and lay it out here. So one thing it does is really accelerates learning and growth, increases confidence because now you feel like, oh, my ideas maybe matter. I know what I'm doing. It decreases the fear of idea sharing, which is really helpful. Increases communication skills. We often underestimate how important it is for developers to have good communication skills, but when you have to talk to people and explain your code, it's really useful. Mentees also feel more invested, right? And they feel more valued as well. And this is the statistic I was looking for. So Sun Microsystems found that mentees are actually 5 times more likely to be promoted. Mentees are 5 times more likely to be promoted. Also, mentors are actually 6 times more likely to be promoted, which is super awesome too. For everybody else, right? Not just the mentees, but it's great. There's great perks for mentoring. Great perks for recruiting, reducing the knowledge silos, like we talked about, reduces the hit by a bus factor, of course, as well, and just makes for a more positive collaborative team culture.
So I'm going to skip ahead because I want to talk about some of the things that mentorship includes here right at the end, and then we'll do one last slide and wrap up. But I thought this was really important. So good mentorship includes, for example, things like technical challenges. So you want to have conversations about talking about things like what is state management or functional reactive programming or unidirectional data flow, or how do you write unit tests or read YAML, and what's a microservice? You also want to do professional instruction. So this is important information about development or whatever your profession is that's not taught in depth at universities or boot camps. Like what makes a good requirement? Or what are the roles on a software team? Or how do you participate in a code review? Of course, you want to stress non-technical skills in your mentorship. So this is just keys to being a good employee and a good person. So how to manage office politics or to be a good follower or good leader, emotional intelligence, and how to speak to clients and other developers and bosses. Of course, career development is a big part of that, helping people understand what are the areas of development they want to focus on, how they move to their next promotion, and some of the steps that we could go there. And the last piece is radical candor feedback. So this is a really interesting one. It comes from a book by Kim Scott, and what we see a lot is that mentors tend to give mentees only positive information and positive feedback. They don't actually challenge them in any way. And that can actually harm mentees because they feel like they're doing really, really well. And then when they go out in the world and they get negative feedback, or they find out that they were being sort of like lied to, they feel betrayed and they realize that they missed opportunities to grow because of their mentor. So that's the PAMSTACK. We hope you found it interesting. We did have some things that juniors can help to do, but we'll sum it up just by saying, any of the things that you saw us do, if your teams aren't doing them now, just offer to write things down. And once you've written it down, share it with the team. And they're going to appreciate that you did it, and they're going to, hopefully make that official. If you have any other questions about, how to implement some of these things, feel free to reach out to us after the session or on Twitter or anything like that. So thank you, everybody, for attending, and we hope you enjoyed.